Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the nth term. If you need any extra help on the nth term, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 288, there's a dedicated video tutorial there on the nth term. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number 1. Question number 1 says, here are the first 5 terms in a number sequence, and the terms are 7, 10, 13, 16 and 19. And part A says, find the 10th term in this number sequence. Okay, so we want to find the 10th term. So to find the 10th term of the sequence, one approach would be to find the nth term and then substitute in 10 for n, and then that would work out the 10th term of the sequence. Alternatively, we could just carry on the sequence. So what I'm going to do is, in part A here, is I'm just going to carry on the sequence and find the 10th term in the sequence. And then part B, we've been asked to find the nth term. We'll then find the nth term, and I'll show you how you could use that to do part A as well. So we've got the sequence 7, 10, 13, 16 and 19. Each time the numbers are increasing by 3. We're adding 3, adding 3, adding 3, adding 3. So let's add another 3, that'll be 22. Add another 3, that'll be 25. Add another 3, that'll be 28. Add another 3, that'll be 31. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So we want the 10th one, so one more, add another 3 would be 34. So that means the 10th term in that sequence is 34. And that's it. Okay, and then part B. Part B says write an expression in terms of n for the nth term in the number sequence. So we want to find the nth term of that sequence. So the sequence was 7, 10, 13, 16, 19. And if I want to find the nth term for that sequence, what I do is I have a look and see what's happening to the sequence. It's getting bigger by 3 each time. And in terms of numbers that get bigger by 3 each time, I'm thinking of the multiples of 3. So 3, 6, 9, 12, 15. And we're going to call that 3n because that's 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9 and so on. So 3n is the 3 times tables, those multiples of 3. 3, 6, 9, 12, 15. Now we want to find the nth term not of 3, 6, 9, 12, 15, but of this sequence, which was 7, 10, 13, 16 and 19. And as you can see, these numbers in the sequence are actually 4 greater than these numbers here. If we add 4 to 3, we get 7. If we add 4 to 6, we get 10. If we add 4 to 9, we get 13, and so on. So that means that our sequence is 3n, the 3 times tables, plus 4. So 4 bigger than them, and that's it. So the nth term for this sequence would be 3n plus 4. And that's it. And let's go back to part A. Part A said to find the 10th term of the sequence, and we found it by writing out the first 10 terms of the sequence. Now, if it was the 20th term, that'd be quite time consuming, and the 100th term, even more time consuming. So it can be quite useful to use the nth term to work out these questions. So if we want to find the 10th term, we do 3 times n, so 3 times 10 is 30. Plus 4 is 34. So that's fantastic. We got 34 both ways. We got it by carrying on the sequence, but we also got it by finding the nth term and substituting in 10 for n. Okay, let's look at our next question, question number 2. So question number 2 says, a number sequence is an nth term of 6n plus 3. And part A says to write down the first 4 terms in that sequence. So we want to find the first 4 terms of the sequence. So there's a couple of approaches we could use here. One approach is to find the first term, we'd substitute in 1. To find the second term, we'd substitute 2. To find the third term, we'd substitute in 3. And to find the fourth term, we'd substitute in 4 for the value of n. And let's do that to begin with. So to find the first term, we would do 6 times n. So it's going to be 6 times 1 because it's the first term, 6 times 1 plus 3. And 6 times 1 is 6 plus 3 would be equal to 9. So that's equal to 9. So that means the first term of the sequence is 9. The second term of the sequence, we're going to do 6 times 2, which is 12, plus 3 would be equal to 15. So 6 times 2 is 12, plus 3 is equal to 15. So that's the second term of the sequence, 15. The third term in the sequence, we're going to do it instead of 6 times 1 and 6 times 2, we're now going to do 6 times 3. So 6 times 3 plus 3. 6 times 3 is 18, plus 3 is 21, so that's 21. And finally, if we want to find the fourth term, we substitute in 4 for the value for n. So the fourth term, we're going to do 6 times 4 and then plus 3. And 6 times 4 is 24, plus 3 would be 27, so that'd be 27. So that means the first 4 terms of the sequence are 9, 15, 21 and 27, and that's it. Now another approach would be to look at the nth term and say, well, we've got 6n, so think of the multiples of 6, those numbers in the 6 times tables, that's 6, 12, 18, 24. And then we've got plus 3, so that means 3 bigger. So if we add 3 to each of these, we'd get 9, 15, 21, and 27. And they're the first 4 terms of that sequence. And that's it. And then if we have a look at part B says, Sarah says that 1008 is a term in the sequence. Explain why she's wrong. So there's a couple of approaches that we could use here. One approach actually, and I think the easiest approach, is to look at the numbers in the sequence. The numbers in the sequence go 9, 15, 21, 27. And if we carry on with the sequence, you'll find that all of those numbers are odd. 9's odd, 15's odd, 21's odd, 27's odd, and so on. So if we added on another 6 to get the next term, it would be 33, and so on. So all the terms in the sequence are odd. So that means that 1008, which is even, would not be in the sequence. So let's explain that. And that's it. I've just explained, and I'll read this out just in case you can't read my handwriting here. I've done it quite quickly. It says that as all the terms in the sequence, 9, 15, 21, and 27, are odd, and 1008 is even, it's not in the sequence. And that's it. Now, I did mention there was another approach, and the other approach that you could use is to actually look at the nth term, which was 6n plus 3. So we could write, and I'm just going to change colour of ink here to blue, you could write 6n plus 3, that's the nth term of the sequence, and we could put that equal to 1008, because we want to see, is 1008 a term in the sequence? And one way to see if a term's in a sequence or not is you could put it equal to the nth term, solve the equation, and if you find the value of n to be a whole number, such as 7 or 10 or 52, it's a term in the sequence. But if it's a decimal number, then that's not possible in terms of n. Remember, n's a term in the sequence. So if you get a decimal number, then it wouldn't be in the sequence. So let's just check this. Now, this is a non-calculator question, so I think the first approach is actually much easier, actually, just to say, well, all the terms in the sequence are odd, and that's even. So, and it's a 1-mark question, so I think that probably would be the approach that I would use here in red. But just to show you that if you solve this equation and take away 3 from both sides, so take away 3 and take away 3, we get on the left hand side, we're taking away 3 to get rid of the plus 3, so we'll be left with 6n. And on the right hand side, 1008, take away 3 would be 1005. Now we want to find out what n is, the term in the sequence, so we're going to divide by 6 and divide by 6. 6n divided by 6 would just be n, so we're dividing by 6 to get rid of the times by 6. And then if we do 1005 divided by 6, and you would need to use a bus shelter method for this, and that's why I think for this question being a 1-mark question, that's the best approach. But just to show you, I'm just going to get a calculator and do it quickly. 1005 divided by 6 is equal to 167.5. So that means that 1008 would be the 167.5th term in the sequence. So in other words, it's between the 167th and 168th term in the sequence. So that means that that's not in the sequence. So no, it's not in the sequence. And that's it. And actually, just to mention there, whenever we done the 1005 divided by 6, there's no reason why we couldn't do that without a calculator and just say how many 6's going to 1, 0 remainder 1. How many 6's going to 10? That's going to be 1 remainder 4. How many 6's going to 40? That's 6, and then remainder would be 4. How many 6's going to 45? That'll be 7, which is 42. And then remainder 3, you could put a decimal point at 0, remainder 3. And then how many 6's going to 30? That's 5. So that'll be 167.5. And again, that's not a whole number, so that means that 1008 is not a term in the sequence. And that's it. And as I've said a few times already, I think that's a much easier approach in terms of this question. Okay, let's have a look at our next question, question number 3. So question number 3 says a sequence of numbers is shown below. And we've got 1, 5, 9, 13, 17, blank and blank. And part A says find an expression for the nth term of the sequence. So we want to find the nth term for the sequence, which is 1, 5, 9, 13, 17. Okay, so we've got our sequence 1, 5, 9, 13, 17. We want to find the nth term of the sequence. So what I'm going to do is I'm going to have a look at the sequence, and I notice that each time we're adding 4. To get from 1 to 5, we add 4. To get from 5 to 9, we add 4, add 4, add 4. So in terms of a series of numbers that get bigger by 4 each time, I'm thinking of the 4 times tables, or the multiples of 4, which would be 4, 8, 12, 16, and 20. And we're going to call those 4n, because 4n is the 4 times tables. 4 times 1 is 4, 4 times 2 is 8, and so on. So that's 4n. But our sequence isn't 4, 8, 12, 16, and 20. It's actually only 1, 5, 9, 13, and 17. So that means each term in our sequence is actually 3 smaller. If we've got 4, we take away 3 to get to 1. To get from 8 to 5, we take away 3. To get from 12 to 9, we take away 3. To get from 16 to 13, we take away 3. To get from 20 to 17, we take away 3. So that means the nth term for this sequence would be 4n minus 3, because we've got the 4 times tables, but it's 4 less. And that would be the numbers 1, 5, 9, 13, 17. And that's our nth term. Okay, then part B. Part B says explain why 95 would not be a term in the sequence. Now this time it's not as simple as the one before because 95 is odd and all the numbers in the sequence are odd, but it's obviously not all the odd numbers because it goes 1, 5, 3's not there, 7's not there, 11's not there, and so on. But 95 it's an odd number, so it may be in the sequence, but we've been asked to explain why it's not on the sequence, so let's show that it's not on the sequence. So I'm just going to change colour ink here to red, and we're going to write the nth term, which is 4n minus 3, and we're going to put it equal to 95. And if we solve this equation, and n is a whole number, then that means 95 would be in the sequence. Or if n's a decimal number, then that means it's not on the sequence. And because we want to explain why it's not on the sequence, we want to solve this and find that n's a decimal number. And what's great here is it's a calculator question. So here, we've got 4n minus 3 equals 95. Well, we want to get rid of this minus 3, so let's add 3 to both sides of the equation. So let's add 3, and that gets rid of the minus 3. So then on the left-hand side, we'll be left with 4n, and the right-hand side with 95, and then we're adding 3, so that'll be 98. And now we want to find out what n is. We don't want 4n, so we want to get rid of this times by 4. So we're going to divide by 4 and divide by 4. On the left-hand side of the equation, we had 4 times n. We're dividing by 4 to get rid of the times by 4, so we're just going to be left with n. And on the right-hand side of the equation, we had 98. We're going to divide that by 4 on our calculator, and we get that's equal to 24.5, so 24.5. So that means that n is equal to 24.5. That means that 95 would be the 24.5th term in the sequence, which isn't possible. It must mean that 95 is in between the 24th term and the 25th term. So let's explain that. And that's it. I've just put a cross out to say that it's not in the sequence. And I've written that 95 is in between the 24th term and 25th terms of the sequence. Okay, let's have a look at our next question, question number 4. Okay, so question number 4 says the nth term of a sequence is given by 5n plus 2. On part A, we've been asked to write down the first 3 terms of the sequence. So we've got the nth term and we want to find the first 3 terms. So what I'm going to do is I'm going to substitute in 1, I'm going to substitute in 2, I'm going to substitute in 3. So let's just go to this in our head. We don't need to write it out in full. 5 times 1 is 5, plus 2 would be 7, so the first term is 7. 5 times 2 would be 10, plus 2 is equal to 12. And then finally, the third term, 5 times 3 is 15, plus 2 is equal to 17. And that's it. Alternatively, remember, we could write down the multiples of 5, so 5, 10, 15, and then add 2 to get 7, 12, and 17. Okay, then if we carry on, and then we're told, here are the first 5 terms of another number sequence, 5, 11, 17, 23, 29. And part B, we've been asked to find, in terms of n, an expression for the nth term of that sequence. So we want to find the nth term of 5, 11, 17, 23, and 29. So each time the numbers are getting bigger by 6. We're adding 6, adding 6, adding 6, adding 6. So in terms of numbers that get bigger by 6 each time, I'm going to write down 6, 12, 18, 24, and 30. Because here we've got our multiples of 6, 6, 12, 18, 24, and 30. And we're going to call that 6n because 6 times 1 is 6. 6 times 2 is 12, and so on. So that's 6n. But our sequence isn't 6, 12, 18, 24, and 30. It's actually one less. It's 5, 11, 17, 23, 29. So we're going to take away 1. So it's going to be 6n minus 1. So our expression in terms of n for the nth term of that sequence would be 6n minus 1. And that's it. Okay, let's look at our next question, question number 5. So question number 5. Question number 5 says a sequence of numbers is shown. So we've got the sequence of numbers 2, 9, 16, 23, and 30. And part A says find an expression for the nth term of the sequence. So we want to find an expression for the nth term of the sequence. So 2, 9, 16, 23, and 30, and so on. Okay, so in terms of these numbers, we're starting with 2, and each time we're adding 7. So 2 plus 7 is 9, plus 7 is 16, plus 7 is 23, plus 7 is 30. So each time the sequence is increasing by 7. So in terms of numbers that are getting bigger by 7 each time, I'm thinking 7, 14, 21, 28, and 35. And that's going to be 7n. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, and so on. So because the sequence is getting bigger by 7 each time, we've written down 7, 14, 21, 28, 35, that's 7n. But in terms of our sequence, it's not 7, 14, 21, 28, and 35. To get from the multiples of 7 to our sequence, we're going to have to take away 5. We would take away 5, take away 5, take away 5, take away 5, and take away 5 to get our sequence. So that means our sequence is got an nth term of 7n subtract 5, and that's it. Okay, and then part B. Part B says find the 100th term in the sequence. So we could go back up to the sequence and carry on the sequence to get the first 100 terms, but for a 2-mark question in an exam, I wouldn't do that. To get the 100th term in the sequence, we've got the nth term, which is 7n minus 5. So we just need to do 7 times 100 to take away 5, because if you want to find a particular term in the sequence, you substitute in that term number into the nth term. So we're going to do 7 multiplied by 100, take away 5. And 7 times 100 is 700. Take away 5 would be 695. So that means the 100th term in the sequence is 695. And that's a lot quicker than writing down 100 terms of a sequence. Okay, so let's have a look at our next question, question number 6. So question number 6 says, here's a linear sequence. So we've got this linear sequence, 10, 16, 22, and 28. Each time the sequence is getting bigger by 6. And we've been asked to circle the nth term of the sequence. And our choices are 4n plus 6, n plus 6, 6n plus 4, and 6n. So to find the correct answer, what I'm actually going to do is find the nth term of the sequence. So we've got 10, 16, 22, 28, and so on. And each time it's getting bigger by 6. So I'm going to write down the multiples of 6 beneath the sequence. So 6, 12, 18, 24, and that's 6n. But to get our sequence of 10, 16, 22, and 28, we're going to have to add 4 each time. So that means the nth term of the sequence will be 6n plus 4. So that means the correct answer is 6n plus 4. And that's it. Now, in terms of this question, what I could have actually done was to rule some options out. Because the sequence is getting bigger by 6 each time, I know that it would be 6, 12, 18, 24. I'd write down those multiples of 6 beneath, and I'd call that 6n. So I know there's going to be a 6n. So I know it's not going to be 4n plus 6, because that'll be a sequence of numbers that's getting bigger by 4 each time. So it's not going to be that one. N plus 6, well, that's 1n plus 6. So that sequence, each of the terms are just getting bigger by 1 each time. So it's not going to be that one. And this one, 6n, would just be 6, 12, 18, 24. We actually know that 10, 16, 22, and 28 would actually be a certain amount bigger than the multiples of 6. It'd actually be 4 bigger. So it'd be 6n plus 4. And that's it. Okay, let's look at our next question, question number 7. So question number 7 says the nth term of a number sequence is n squared plus 3. And part A says find the first 3 terms of the sequence. So to find the first 3 terms of the sequence, we're going to substitute in values of n of 1, 2, and 3. We're going to do 1 squared plus 3. 2 squared plus 3, and 3 squared plus 3, and that'll give us the first 3 terms of the sequence. So in terms of the first term in the sequence, we would do 1 squared plus 3. And 1 squared is 1, plus 3 is equal to 4. So the first term of the sequence is 4. The second term in the sequence, we would do 2 squared plus 3. So we're going to do 2 squared, that's equal to 4, plus 3 is equal to 7. So the second term of the sequence is 7. And then the third term in the sequence, we're going to do 3 squared plus 3, 3 squared plus 3. And 3 squared is equal to 9, plus 3 is equal to 12. So the first 3 terms in the sequence are 4, 7, and 12. Now you may notice here that when you've got the terms 4, 7, and 12, you get bigger by 3 and then get bigger by 5. And the reason is this is a quadratic sequence. It's got something squared. So when you've got something squared, it's not going to get bigger by the same amount each time. It's not a linear sequence. This one's a quadratic sequence. But to find the first 3 terms of the sequence, we just need to substitute in values of 1, 2, and 3 into n. And then you'd work that out, and then that would be the terms in the sequence. Okay, then part B. Part B says work out the difference between the 5th term and the 10th term in the sequence. So we want to find the difference. The difference, remember, is what we get when we subtract 2 numbers. So we need to work out the 5th term in the sequence and the 10th term in the sequence and then subtract them. So let's find the 10th term to begin with, the 10th term. So in terms of the 10th term, we're going to do 10 squared plus 3. So we're going to do 10 squared plus 3. And 10 squared is 100 plus 3 would be 103. So the 10th term in the sequence is 103. The 5th term in the sequence, the 5th term, I'm just going to scroll down a bit here. The 5th term would be 5 squared plus 3. So 5 squared plus 3. 5 squared is equal to 25 plus 3 would be 28. So the 5th term in the sequence is 28. So that's fantastic. We've worked out the 10th term and the 5th term in the sequence. Now it's a calculator question, but these were actually quite straightforward without a calculator. Now we want to find the difference, so we're going to subtract them. We're going to do 103 take away 28. And if we do 103 take away 28, the difference will be the difference between the 5th term and the 10th term in the sequence. That'll be our answer. So if we do 103 take away 28, that's equal to 75. So the answer is 75. The difference between the 5th term and the 10th term in the sequence is 75. And that's it. Okay, let's have a look at our next question, question number 8. So question number 8 says the first 5 terms in a number sequence are 10, 7, 4, 1, and negative 2. And part A says work out the nth term of the sequence. We want to find the nth term of this sequence. Now this sequence is a little bit different than the ones we've looked at so far, because rather than getting bigger, it's getting smaller. We're taking away 3, taking away 3, taking away 3, taking away 3. So every single time we're subtracting 3. So that means rather than having 7n or 5n or something like that, we're going to have a negative 3n. Because it's decreasing by 3 each time, we're going to have negative 3n. So we're going to do negative 3, negative 6, negative 9, negative 12, negative 15. Just doing negative 3 times 1, negative 3 times 2, negative 3 times 3, and so on. Or because it's getting smaller by 3 each time, we're just going negative 3, negative 6, negative 9, negative 12, negative 15. So that's negative 3n. But we didn't want the nth term for this sequence, we wanted the nth term for the sequence above. So let's see how we go from our values in red, which would be negative 3n, up to our sequence. So to get from negative 3 to 10, we add 13. To get from negative 6 to 7, we add 13. To get from negative 9 to 4, we add 13. So the nth term of the sequence would be negative 3n plus 13. And that was it. That would be the nth term of that sequence. Now, you might actually write this a slightly different way. You might encounter it a slightly different way. Rather than being negative 3n plus 13, some people might write it as 13 subtract 3n. They do the whole thing the same. So they start off with numbers getting smaller by 3 each time. So negative 3, negative 6, negative 9, and so on. They write negative 3n and then figure out it's plus 13. And then they just write it the way around, where it's 13 subtract 3n rather than minus 3n plus 13. So you can write it either way. You write 13 subtract 3n or negative 3n plus 13. And that's it. Okay, now let's look at our next part, part B. Part B says find the 50th term in the sequence. So again, rather than carrying on the sequence for the first 50 numbers, I'm going to use the nth term. And I could use either negative 3n plus 13. I could use that as the nth term and, work it out that way. Or I could use the other one. And I'll just do both to show you that they both work. So in terms of the 50th term, we're going to substitute that value of 50 in for n. So instead of it being negative 3 times n, we're going to do negative 3 times 50. And then we've got plus 13. And then we can just type this into our calculator. Negative 3 times 50 plus 13 is equal to negative 137. So that means the 50th term in the sequence is negative 137. And that's it, negative 137. And just to mention, you could have used the other nth term of 13 minus 3n, and you would just do 13 subtract 3 times 50. And then again, you could type that into your calculator and you get negative 137. And that's it. Okay, let's look at our next question, question number 9. So question number 9, we've been asked to work out the nth term of this sequence, 12, 22, 32, 42, and 52, and so on. So in terms of this sequence, you can see it's getting bigger by 10 each time. So let's write down our multiples of 10, 10, 20, 30, 40, 50, and so on. And that would be 10n. And then to get from our multiples of 10 to our sequence, we would need to add 2. So our nth term will be 10n plus 2. So it's 2 more than the 10 times tables. And that's it. So the nth term of this sequence is 10n plus 2. Okay, let's have a look at our next question, question number 10. So question number 10 says the nth term of a sequence is 3n subtract 2. On part A, we've been asked to write down the first 2 terms of the sequence. So you just want to find the first 2 terms of this sequence. So we're going to substitute in 1 and 2 for the values of n. So in terms of the first term in the sequence, we're going to do 3 times 1 and then take away 2. 3 times 1 is 3, take away 2 is 1. So the first term in the sequence will be 1. And then in terms of the second term of the sequence, we're going to do 3 times, and then instead of n, it's going to be 2, and then subtract 2. And 3 times 2 is 6, take away 2 is 4. So the second term of the sequence is 4. Okay, and then let's have a look at our next part, part B. So part B says which term of the sequence is equal to 70? So we could carry on the sequence. We could do 1, 4, and then we know it's getting bigger by 3 each time. So it's then going to be 7, 10, 13, and so on. Just add them 3 each time, and we could carry on until we get to 70, but that's quite time consuming. That's not the approach that I would use. So in terms of how I would do this question, I would just take the nth term, which is 3n subtract 2, and I'd put it equal to 70. And then if we solve that equation, it'll tell you which term in the sequence has got a value of 70. So if we solve this equation, we want to get the n on its own. So we want to get rid of this take away 2, and then we want to get rid of the multiply by 3. So to get rid of this take away 2, we're going to do the inverse, which is add 2 to both sides of the equation. On the left hand side of the equation, we're adding 2 to get rid of the minus 2, so we're just going to be left with 3n. And then on the right hand side of the equation, we had 70, we're adding 2, so that would be 72. So we've now got the 3n is equal to 72. We don't want this multiplied by 3 here, so we're going to divide by 3 and divide by 3. 3n divided by 3 would be 1n, or just n. And also remember that we're dividing by 3 to get rid of the times by 3, so we'll just be left with n. On the right hand side of the equation, we had 72 divided by 3 is equal to 24. So that means the 24th term of the sequence is equal to 70. And that's it. Okay, then part C. Part C says explain why 101 is not a term in this sequence. So let's just go up and check and see if all the terms in our sequence are even, perhaps, then that would be great because 101 is odd. So let's have a look at our sequence again. 1, 4, so odd, even, and so on. So no, that's not going to be there's not going to be a quick way out of it like that. Okay, so what I'm going to do is explain why 101 is not a term in the sequence. I'm going to take the nth term again, 3n minus 2, and I'm going to put it equal to 101. If we solve this equation, and it's a whole number, we'll know that 101 is in the sequence. But if it's a decimal number, then we'll know that 101 is not a term in the sequence, and it'll be in between two particular terms. And then we can explain that. So if we want to solve this equation, again, we'll want to get rid of this minus 2, and then we'll want to get rid of this multiplied by 3. So to get rid of this minus 2, we're going to do the inverse, which is add 2 to both sides of the equation. So on the left-hand side of the equation, we had 3n minus 2. We're adding 2 to get rid of the minus 2, so we'd just be left with 3n. And then on the right-hand side of the equation, we had 101. We're adding 2, so that'd be 103. Now we want to get rid of this times by 3, so let's divide by 3 and divide by 3. 3n divided by 3 would just be n, or 1n or n. And then 103 divided by 3, 103 divided by 3 is equal to 34.333 and so on. So it's not a whole number, it's a decimal number. So that means that 101 would be in between the 34th term in the sequence and the 35th term in the sequence. So let's explain that. And I've just explained that 101 would be between the 34th and 35th terms of the sequence. And that's it. Okay, let's have a look at our next question, question number 11. So question number 11, we're told here are the nth terms of 4 sequences. So sequence 1, sequence 2, sequence 3, and sequence 4, and we've got their nth terms. So 3n plus 1, 5n plus 10, 10n, and 5n subtract 1. And we're asked for each of the sequences to state whether the numbers in the sequence are always multiples of 5, sometimes multiples of 5, or never multiples of 5. So we need to say if it's A, which means always multiples of 5, so all the terms are all multiples of 5, S, which means the terms of the sequence are sometimes multiples of 5, and N, never multiples of 5. And then we can write our answers down here. So let's look at these one at a time. So let's start off with sequence 1. So sequence 1. So in terms of sequence 1, it's 3n plus 1. So let's generate the terms of the sequence. So 3 times 1 is equal to 3, plus 1 is equal to 4. 3 times 2 is 6, plus 1 is equal to 7. 3 times 3 is 9, plus 1 is equal to 10. 3 times 4 is 12, plus 1 is equal to 13. And as you can see here, we've got our terms of our sequence, 4, 7, 10, 13. And they're getting bigger by 3 each time. So then it'd be 16, 19, 22, and so on. So that's the terms of the sequence, 4, 7, 10, 13, 16, 19, 22, and so on. Another way to do it is to actually consider it's the 3 times tables, but one bigger than it. So if you had the 3 times tables and added 1 to them, you'd get 4, 7, 10, 13, 16, 19, 22, and so on. Now, if we have a look at the sequence, are the terms always multiples of 5? Well, no. The first term in the sequence is 4, so that's not a multiple of 5. 7's not a multiple of 5. 10 is a multiple of 5, though. 13's not, 16's not, 19's not, 22's not, and so on. But here we have got that 10's a multiple of 5, so there's sometimes multiples of 5. There are some multiples of 5, but they're not all multiples of 5. So for the first sequence, it's going to be an S, sometimes multiples of 5. Okay, let's look at our next sequence, 5n plus 10. So let's write that down, sequence 2. So in terms of sequence 2, the nth term is 5n plus 10. So let's do 5 times 1, which is 5, plus 10 is 15. So that's the first term in the sequence. 5 times 2 is 10, plus 10 is 20. Our next term, 5 times 3 is 15, plus 10 is 25. 5 times 4 is 20, plus 10 is 30, and so on. So here, as you can see here, we've got 15, 20, 25, 30, so that'd be 35, and so on. So that's our sequence there, that's sequence 2. And in terms of these, let's have a look at them. Are they always multiples of 5? Well, 15, 20, 25, 30, 35, yes. So in the sequence 5n plus 10, they're always going to be multiples of 5. And actually, if you think about it, it's 5n, which means the multiples of 5, but 10 more. So if you have the 5 times tables and add 10 to it, you're going to get always numbers that are in the 5 times tables, because obviously you've got numbers that are in the 5 times tables and you're adding 10, which is in the 5 times table, so they'll all be multiples of 5. So that's going to be A, always. Okay, sequence 3. So sequence 3, I'm going to do it up here, sequence 3. So sequence 3, the nth term is 10n. So 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30 and 40 and so on. And in terms of these terms, we've got 10. That's a multiple of 5. 20 is a multiple of 5. 30 is a multiple of 5. 40 is a multiple of 5. All the terms in the sequence are always going to be multiples of 5. So again, that's going to be A as well. So that's an A for that sequence, A. So we've got sequence 1, sometimes multiples of 5. Sequence 2, always multiples of 5. Sequence 3, always multiples of 5. Let's have a look at sequence 4. So sequence 4. Sequence 4. So that is 5n minus 1. So 5 times 1 is 5. Take away 1 is 4. 5 times 2 is 10. Take away 1 is 9. 5 times 3 is 15. Take away 1 is 14. 5 times 4 is 20, take away 1 is 19, and so on. So as you can see here, we've got the numbers 4, 9, 14, 19, then it'll be 24, 29, 34, 39, and so on. And as you can see, it's always one less than a multiple of 5. 4 is one less than a multiple of 5. 9 is one less than a multiple of 5. 14 is one less than a multiple of 5. So here, none of the terms in the sequence are ever going to be a multiple of 5. So for sequence 4, it's going to be n. So let's write that down, n. And that means our answers will be sometimes, always, always, and never. And that's it. Okay, so let's have a look at our next question, question number 12. So question number 12 says the first 4 terms of an arithmetic sequence are negative 25, negative 37, negative 49, and negative 61. And we've been asked to find an expression in terms of n for the nth term of the sequence. So we want to find the nth term of the sequence. And it's a calculator question, so that might come in handy. So here we've got negative 25, negative 37, negative 49, and negative 61. And as you can see here, each time it's going down by 12. We're subtracting 12, subtracting 12, subtracting 12. So you can check that in your calculator. You can take negative 25 and take away 12. You'll get to negative 37. Take away another 12. You get to negative 49 and so on. So let's write down the numbers in the negative 12 times table. So negative 12, negative 24, negative 36, and negative 48. And that would be negative 12n. Now to get from the numbers in the negative 12 times table, so our sequence, well, to get from negative 12 to negative 25, we're going to have to take away another 13. Because if you're at negative 12 and you want to go on down to negative 25, you're going to have to take away 13. To get from negative 24 to negative 37, you're going to have to subtract 13. To get from negative 36 down to negative 49, you're going to have to take away 13. So that means the nth term will be negative 12n subtract 13. And that's it. So that's the nth term of that sequence. Negative 12n subtract 13. Okay, let's look at our next question, question number 13. Okay, so question number 13, we're told the nth term of a sequence is 5 subtract 3n. And we've been asked to write down the first 3 terms of the sequence. So we want to find the first 3 terms of that sequence. So the first term, well, we're going to do 5 subtract 3 times n. Remember, to find the first term, we're just going to substitute 1 in for the value of n. So we're going to do 5 subtract 3 times 1. 3 times 1 is equal to 3. Remember our order of operations, we've got to do the multiplication first. So you're going to do 3 times 1 first. So 5 subtract, and 3 times 1 is equal to 3. And 5 subtract 3 would be equal to 2. So the first term of the sequence is 2. The second term of the sequence, again, we're going to do 5 subtract 3 times, and we're going to substitute in 2 for the value of n. Remember, we have to do the multiplication first, so we're going to do 3 times 2 is 6, so we've got 5 subtract 6. And 5 subtract 6 is equal to negative 1. And then in terms of the third term in the sequence, we're going to do 5 subtract 3 times, and we're going to substitute in 3 for the value of n, so that'll be 3. 3 times 3 is equal to 9, so we've got 5 take away 9, and 5 subtract 9 will be equal to negative 4. So that means the first term of the sequence is 2, the second term of the sequence is negative 1, and the third term of the sequence is negative 4. And as you can see here, they're decreasing by 3 each time. We're taking away 3, taking away 3. And that's good because as you can see here, we've got negative 3n. So it means that the sequence should be going down by 3 each time. So the first 3 terms of the sequence are 2, negative 1, and negative 4. Okay, let's look at our next question. Okay, it's question number 14. Question number 14 says the nth term of a sequence is 4n subtract 7. And we've been asked to write down the first 3 terms of the sequence. So we want to find the first 3 terms in the sequence. So let's substitute in 1, 2, and 3 for the values of n. So we're going to do 4 times 1. So 4 times 1 is equal to 4. Take away 7. So 4 times 1 is equal to 4. Take away 7 is equal to negative 3. So the first term of the sequence is negative 3. The second term of the sequence, 4 times 2 is equal to 8. Take away 7 is equal to 1. So it's going to be 1. And the third term of the sequence, 4 times 3 is 12. Take away 7 is equal to 5. So that would be 5. So that means the first 3 terms in the sequence are negative 3, 1 and 5. And as you can see, adding 4. And that's good because it's 4n, so it means it should increase by 4 each time. And then part B says, what is the difference between the 150th term and the 151st term? So we've been asked to find the difference between those two terms. Remember, the word difference means to take them away. Now, this question, if we go down, it's a 1-mark question. Now, one way to do this question, and this would give you the right answer, is to substitute in 150 in for n and 151 in for n, and work out those terms. So work out the 150th term by doing 4 times 150, which is 600, and take away 7, which would be 593. And then find the 151st term in the sequence by doing 4 times 151, and then take away 7. And then to take away those two answers and see what's the difference between them. So that's one way to do it. But another thing to notice is here is that we've got the 150th term and the 151st term. That's the next term. Now remember, we just said that each time the sequence is getting bigger by 4. It's getting bigger by 4, getting bigger by 4, getting bigger by 4. So it means that any two consecutive terms, any two terms that are next to each other, will have a difference of 4. Because remember, each time we're adding 4. The next time would be 9, the next time would be 13, and so on. So whatever the 150th term is, the 151st term will be 4 more than it. So that'll be the difference, 4. Whenever you take them away, the answer will be 4. So that's it, 4. And for a 1-mark question, that's what I would do. But if you went blank or you didn't notice that, you could just do 4 times 150, which is 600. Take away 7 would be 593. If you do 4 times 151, that's equal to 604. Take away 7 would be 597. And then if you take them away, you'll get an answer of 4. That's the difference between them. But I think the easiest way there would be just to notice the sequence is always getting bigger by 4 each time. And then if we carry on, we're told the last term in the sequence is 393. How many terms are there in the sequence? So the nth term is 4n subtract 7. So 4n subtract 7. And that's the last term in the sequence. So if we put it equal to 393 and solve that equation, the value for n you get is what term number that is. And we're asked how many terms there are in the sequence. Well, that'll be your answer, n. So let's solve this equation. So if we wanted to solve this equation, we're going to add 7 to both sides to get rid of this minus 7. So add 7 and add 7. On the left hand side, we had 4n subtract 7. We're adding 7 to get rid of the minus 7. So we're going to be left with 4n. And on the right hand side of the equation, we had 393. We're adding 7. That's 400. And now this is quite nice. We want to find out what n is. Well, 4 times 100 is 400. Or divide both sides of the equation by 4 and get the n is equal to 100. So there's 100 terms in that sequence. And that's it. Okay, let's have a look at our next question, question number 15. So question number 15, we've been asked to find the nth term of these sequences, and we've got part A, part B, part C, and part D as well, if we scroll down a bit. And in terms of this question, it's a bit different than the rest of the questions in this booklet in terms of we're finding the nth term, but it's not a linear sequence. These sequences aren't getting bigger and smaller by the same amount each time. If we have a look at the first one, we're adding 3, adding 5, adding 7, adding 9, and so on. So this question is just, it's a bit of an interesting one in terms of these are quadratic sequences, but they're quite nice ones. So I haven't put it into the quadratic sequences booklet. I've just put it here just because you might be able to spot this question. But in terms of this booklet, if you can do the other questions in this booklet, and question 15 is the only one that's causing you a bit of trouble, don't panic. That means you're doing fantastically well on the nth term. Okay, so in terms of this question, we've got find the nth term of this sequence. So part A, we've got 1, 4, 9, 16, 25. Now these are square numbers. 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So the nth term of the sequence would be n squared. It's the term number squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So for part A, the nth term is n squared, and it's just more something you might be able to spot. Okay, and then part B. Part B, part C, and part D are all going to use this fact here. If the nth term for this sequence is n squared, we're maybe doing something to these numbers to get the other ones. So part B, we've got 3, 6, 11, 18, 27. Now if you notice here, to get from 1 to 3, you add 2. To get from 4 to 6, you add 2. To get from 9 to 11, you add 2. To get from 16 to 18, you add 2. To get from 25 to 27, you add 2. So these numbers are all 2 greater than these ones. So that means the nth term for this sequence will be n squared plus 2. It's just 2 more than these numbers. So it's n squared plus 2. It's the number squared, and then add 2. 1 squared is 1, add 2 is 3. 2 squared is 4, add 2 is 6. 3 squared is 9, add 2 is 11, and so on. And that's it. Okay, and let's have a look at our next part, part C. So part C, we've got -3, 0, 5, 12, 21. So remember I said that parts B, C, and D were all linked into that first part A. So I'm just going to write that down again. 1, 4, 9, 16, 25. That's the sequence with the nth term of n squared. So here, to get from 1 to -3, we would take away 4. To get from 4 to 0, we take away 4. To get from 9 to 5, you take away 4. To get from 16 to 12, you take away 4. So this sequence would have an nth term of n squared, take away 4. It's our square numbers, but 4 smaller. Okay, then finally D. If we have a look at D, for D, the terms in the sequence are 2, 8, 18, 32, 50. Those numbers are double our square numbers. If we double 1, we get 2. If we double 4, we get 8. If we double 9, we get 18. If we double 16, we get 32. If we double 25, we get 50. So that means that this sequence would have an nth term of 2n squared. 2 times n squared. You're multiplying n squared by 2. And that's it. So question 15 is a bit trickier than the other ones, I think. It's just more spotting that these are the square numbers, which would be n squared, and then these ones, you're just adding 2 to all of them, taking away 4, and then finally doubling. And that's it. Okay, let's have a look at our next question, question number 16. So question number 16 says the nth term of a sequence is 9n plus 7. And we've been asked to write down all the numbers from the sequence that are prime and less than 100. So what I'm going to do here is, well, because we know that the numbers that we're looking for are less than 100, let's generate all the terms in the sequence that are less than 100. So let's find the first term, second term, third term, and so on, until we get to the last term in the sequence that's less than 100. And then we can select the prime numbers from that list. Okay, so if n is equal to 1, 9 times 1 is equal to 9, plus 7 is equal to 16. So that's the first term in the sequence. 9 times 2 is equal to 18, plus 7 is 25, so that's the second term in the sequence. 9 times 3 is 27, plus 7 is equal to 34. 9 times 4 is equal to 36, plus 7 is equal to 43, and so on. Now here, one thing I've noticed here is we've got 9n plus 7. So remember, if we were generating this sequence, we would be writing down all the multiples of 9 and then adding 7. So this sequence is getting bigger by 9 each time. If we have a look here, 16 plus 9 is 25. 25 plus 9 is 34. 34 plus 9 is 43. So let's just keep adding 9. So 52, 61, 70, 79, 88, and 97. I'm not going to add another 9 because then we would have a term that is bigger than 100 when we're looking for numbers in this sequence that are prime and less than 100. So now let's find the prime numbers in this list. So remember, a prime number is a number that's only divisible by 1 and itself. So 16. So 16 is divisible by 1 and 16, so 1 and itself, but it's also divisible by 2 and 8 and also 4. So 16 is not prime. 25 is not prime because it's divisible by 1 and 25, but also 5, so that's not prime. 34 is divisible by 2, so that's not prime. 43. The only factors of 43 are 1 and 43. So 43 is a prime number, 43. And it's a calculator question, so you can actually use your calculator to help you check that. 52, well, it's divisible by 1 and 52, but also 2, 26, and so on. So 52 is not prime. 61 is prime. 70, that's not prime. 79, that's prime. 88, that's not prime. You can divide it by 1 and 88, but also 2, 44, and so on. So 88 is not prime. And 97 is prime. And that's it. So they're the numbers that we're looking for. 43, 61, 79, and 97. These numbers are all in the sequence. They're all prime, and they're all less than 100. Okay, let's look at our next question, question number 17. Okay, let's look at our next question, question number 17. So question number 17, we're told the first 5 terms in a number sequence are 30, 25, 20, 15, and 10. And we've been asked to find the nth term of this sequence. So this sequence, the terms are getting smaller by 5 each time. They're going down by 5 each time. So let's consider a sequence that's going down by 5 each time. So let's write the numbers in the -5 times table. So -5, -10, -15, -20, and -25. And those numbers would be -5n. So -5 times 1, -5 times 2, -5 times 3, and so on. Now that's -5n, but we want the sequence. So to get from -5n to our sequence, to get from -5 to 30, we would add 35. To get from -10 to 25, we would add 35. to get from minus 15 to 20, we'd add 35. So that means the nth term of our sequence is minus 5n plus 35. And that's it. And you can check that. For instance, the fifth term in the sequence, minus 5 times 5 would be minus 25, plus 35 would be 10. Also, remember, we could write this the other way around. Rather than write to minus 5n plus 35, we could write the 35 first and then write minus 5n. That would also work as well. So 35 minus 5n. Because again, you could check it. 35 minus 5 times n. So if we wanted the fifth term in the sequence, we would do 35 minus 5 times 5. 5 times 5 is 25, and then 35 minus 25 is equal to 10. And that's it. So you can write those either way around. Okay, let's look at our next question, question number 18. So question number 18, we're told here are the first four terms of an arithmetic sequence. So an arithmetic sequence is a sequence that's getting bigger by the same amount each time or smaller by the same amount each time. So we've got 9, 17, 25, 33. So they're getting bigger by 8 each time. So because they're getting bigger by 8 each time, let's write down our multiples of 8. So 8, 16, 24, 32, and we'll call that 8n. And to get from 8 to 9, we add 1. To get from 16 to 17, we add 1. To get from 24 to 25, we add 1. So the nth term of the sequence would be 8n plus 1. And that's it, because these numbers are one more than the 8 times tables. 9, 17, 25, 33. They're all one greater than the 8 times tables. And then if we carry on, we're told the nth term of a different sequence is 20 minus 3n. And we're asked, is negative 71 a term in this sequence? Sure, you're working out. So we could substitute in 1, 2, 3, 4, and so on and see if minus 71 is a term in the sequence, but that'll take quite a lot of time. So if I want to see if a term's in a sequence, I like to put the nth term, so 20 minus 3n, equal to the term. And if it's in the sequence, when you solve this equation, you'll find that n is a whole number, such as 7 or 19 or something like that. So let's solve this equation. There's a couple of different ways we could solve this equation. I'm going to solve it using both approaches, just in case you've used either approach whenever you're solving it. I'm just moving it over here. So one approach is we want to get the n on its own. So let's get rid of this 20, because we don't want this 20 here. So let's take away 20 from the left-hand side and take away 20 from the right-hand side. On the left-hand side, we're taking away 20 to get rid of this 20, so we'll be left with minus 3n, so minus 3n. And on the right-hand side of the equation, we had minus 71. We're taking away 20, so that'll be minus 91. So we've just taken away 20 from both sides of that equation. Now, we want to get the n on its own, so we don't want this multiplied by negative 3. This is negative 3 times n. So if we want to get rid of this times by negative 3, we're going to divide both sides by negative 3. Divide by negative 3. So negative 3n divided by negative 3 would just be n, because we're dividing by negative 3 to get rid of the times by negative 3. And then if we had negative 91 divided by negative 3, well, a negative divided by a negative is a positive, so that's going to be a positive number. Well, that's good. And now we need to do our 91 divided by 3 to see what it's going to be. So 91 divided by 3. So how many 3's go into 9? 3. And then how many 3's go into 1? That'll be 0, remainder 1. So I'm just going to put decimal point in some zeros. Carry on the bus shelter method. So how many 3's go into 1? 0, remainder 1. How many 3's go into 10? 3, remainder 1. How many 3's go into 10? 3, remainder 1, and so on. So we've actually got 30 and a third. So 30.333 and so on. So that means that negative 71 would be in between the 30th term in the sequence and the 31st term in the sequence. So is negative 71 a term in the sequence? The answer is no. And that's it. Okay, let's look at our next question. Okay, so question number 19. So question number 19 says the first 5 terms in a number sequence are 2, 2.5, 3, 3.5, 4, and so on. And part A, we've been asked to work out the nth term of this sequence. That's a calculator question, but actually I think we can do this without a calculator, this part anyway. So we want to find the nth term of this sequence, so let's see what it's getting bigger by each time. Now it's gone from 2 to 2.5, so we've added a half. We've added another half to get from 2.5 to 3. We've added another half to get to 3.5. Or you can consider it as adding 0.5, so adding 0.5, adding 0.5, adding 0.5, and so on, which is a half. So each time we're increasing by a half, we're adding a half each time. So let's think of some numbers that go up by 0.5 each time. So 0.5, 1, 1.5, 2, 2.5, and so on. And that would be 0.5n. So 0.5 times 1, 0.5 times 2. So because the sequence is getting bigger by 0.5 each time, we've just written down the numbers that get bigger by 0.5 each time. Now, to get from 0.5n to our sequence, well, to get from 0.5 to 2, we would add 1.5. To get from 1 to 2.5, we would add 1.5. So that means that the nth term of the sequence would be 0.5n plus 1.5. And that's it. That's the nth term of our sequence. And then part B. Part B, we've been asked to work out the 20th term in the sequence. That's a calculator question, so that's quite nice, but you could do this without a calculator also. So if we want to work out the 20th term in the sequence, we just substitute in 20 into the nth term. So the nth term was 0.5n. So we're going to do 0.5 times 20 and then add 1.5. So you could just type this into your calculator and get that's equal to 11.5. Or you could do 0.5 times 20 is equal to 10. Add 1.5 would be 11.5. So that's it, 11.5. So the 20th term in the sequence is 11.5. You could carry it on if you wanted to, but I think the easiest way is just use the nth term and substitute in 20. Okay, let's have a look at our next question, question number 20. So question number 20 says the fourth term of a linear sequence is equal to 26. And the sixth term of the same sequence is equal to 32. And we've been asked to work out the nth term for that sequence. So what I'm going to do here is I'm just going to put some dashes. That's the first term, the second term, the third term. The fourth term is equal to 26. The fifth term, and then the sixth term is equal to 32. So that's our sequence, and we want to find the nth term of this sequence. So what I want to do is I want to fill in these gaps. Now we know it's a linear sequence, so it's getting bigger by the same amount each time. So to get from 26 to 32, well, that's an increase of 6. To get from 26 to 32, it's gone up by 6. But there's a number in the middle, so that'll be half of 6, which is 3. So we're going to increase by 3 and increase by 3 again. So 26 plus 3 is 29. So it must go 26, 29, 32, because it's getting bigger by 3 each time. So let's go down by 3s to find out what these 3 numbers would be. So going down by 3 would be 23. Going down by another 3 would be 20, and down another 3 would be 17. So that's our sequence. Now we know the sequence, we can find the nth term of it. So if we have a look at the sequence, it's getting bigger by 3 each time. We worked that out already. So let's write down the multiples of 3. So 3, 6, 9, 12, 15, 18. And that would be 3n. 3 times 1, 3 times 2, and so on. So that's 3n, but our sequence is 17, 20, 23, 26, 29, and 32. It's actually going to be, to get from 3 to 17, we'd add 14. To get from 6 to 20, we'd add 14. So that means it's going to be 3n, add 14. That's the nth term of our sequence, 3n plus 14. 3n plus 14. So, and that's it. So whenever you're given questions like this, whenever you're told the fourth term and the sixth term and things like that, what I like to do is I like to put some dashes for the numbers that I don't know, and then perhaps we can work them out, and then we can find the nth term of the sequence quite easily. Okay, let's look at our next question, question number 21. Okay, so question number 21, we're told 5 terms of a sequence are 1, 5, 9, 13, 17. And part A, we've been asked to work out the nth term for this sequence. So we've got 1, 5, 9, 13, 17. So we want to find the nth term. So each time the sequence is getting bigger by 4, we're adding 4, adding 4, adding 4, and adding 4. So let's write down the numbers in the 4 times table. So 4, 8, 12, 16, 20. And that would be 4n. But our sequence isn't 4, 8, 12, 16, 20. It's 1, 5, 9, 13, 17. So to get from 4 to 1, we take away 3. To get from 8 to 5, we take away 3. To get from 12 to 9, we take away 3. So it's going to be 4n minus 3. And that's it. That's the nth term of the sequence, 4n minus 3. Okay, let's go on down. We're then told the first 5 terms of a sequence are 1 12th, 5 23rds, 9 34ths, 13 45ths, and 17 56. And we've been asked to work out the nth term of the sequence. So this is a fractional sequence. And if we have a look at the numerators, each time they're getting bigger by 4. So the numerators form a linear sequence. And then if we have a look at the denominators, 12, 23, 34, 45, and 56. Each time they get bigger by 11. So they form an arithmetic sequence as well. So what we're going to do is we're going to find the nth term for the numerators and the nth term for the denominators. And then we'll write that as a fraction, and that'll be the nth term for the sequence. Now actually, if we have a look at the numerators, 1, 5, 9, 13, 17, we've already worked out the nth term for those in part A. So that means our numerator will be 4n minus 3. That's the numerator of our nth term. Now let's find the nth term for the denominator. So 12, 23, 34, 45, and 56. So each time we're getting bigger by 11. So let's write down the numbers in the 11 times table. So 11, 22, 33, 44, and 55. And that's 11n. Because 11 times 1 is 11, 11 times 2 is 22, and so on. So that's 11n. But our sequence isn't 11, 22, 33, 44, 55. It's 12, 23, 34, 45, 56. It's one more than 11n. So it's going to be 11n plus 1. So we've now found the nth term for the denominator. The nth term for the denominator is 11n plus 1. So that means the nth term for this fractional sequence would be 4n minus 3 over 11n plus 1. And let's just check it. If n's equal to 1 to get the first term in the sequence, 4 times 1 is equal to 4, take away 3 is 1. And 11 times 1 is 11 plus 1 is equal to 12. So that's the first term in the sequence, 112. Let's try it with 2. 4 times 2 is 8, take away 3 is 5. And 11 times 2 is 22 plus 1 is 23. So as you can see, we're generating the sequence using this nth term. So this is right. Okay, let's look at our next question, question number 22. So question number 22, it's another fractional sequence where we've got 2/3, 3/5, 4/7, and 5/9. And part A, we've been asked to find the next term in the number sequence. So the numerators go 2, 3, 4, 5. So the next one's going to be 6. And then the denominators go 3, 5, 7, 9. They get made up by 2 each time. So it's going to be added 2 would be 11. So it'll be 6 11s. And then part B says, find the nth term for this sequence. So because it's a fractional sequence where the numerators are getting bigger by the same amount each time, and the denominators are getting bigger by the same amount each time, we can find the nth term for the numerators, the nth term for the denominators, and then write it as the nth term for the whole sequence. So let's start off with the numerators, 2, 3, 4, 5. So each time they're getting bigger by 1 each time. So let's write down the 1 times tables, 1, 2, 3, 4, and that'll be 1n, or just n. But our sequence is actually one more than those, because we had to get from 1 to 2, we'd add 1. To get from 2 to 3, we'd add 1. So that means the nth term of the numerators would be 1n plus 1, or n plus 1. I'm just going to write it as, instead of 1n, n plus 1. So that means our numerator is n plus 1. Now let's have a look at our denominators, and I'm just going to change colour of ink here to blue, so 3, 5, 7, 9. And in terms of these numbers, they're getting bigger by 2 each time. So let's write down the numbers in the 2 times table. So 2, 4, 6, 8, and that would be 2n. But our sequence is one more than those. To get from 2 to 3, we add 1. To get from 4 to 5, we add 1. So it'll be 2n plus 1. So that means the nth term for the denominators would be 2n plus 1. So that means that our nth term is n plus 1 over 2n plus 1. And let's just check that. So for this fifth term that we worked out to be 6 over 11, or 6 11ths, 5 plus 1 is equal to 6, and 2 times 5 is 10, plus 1 is 11. So that's right. Okay, let's have a look at our next question, question number 23. So question number 23 is a bit similar to question numbers 21 and 22 in terms of it being a fractional sequence. And we're told here are the first 4 terms of a sequence, 7 eighths, 9 11ths, 11 14ths, and 13 17ths. And we've been asked to write down the 20th term in the sequence. We could carry on the sequence if we wanted to, but what I'm going to do is I'm going to find the nth term for the sequence and then substitute in 20 for the value of n and then find the 20th term in the sequence. So let's start off with the numerators. So we've got 7, 9, 11, 13. And each time they're getting bigger by 2. So let's write down our multiples of 2. 2, 4, 6, 8. And that's 2n. 2 times 1 is 2. 2 times 2 is 4, and so on. And to get from our multiples of 2 to our sequence, we're going to add 5, because our sequence is 5 more than the multiples of 2. So it'll be 2n plus 5. So that means for our numerator, the nth term of the numerator is going to be 2n plus 5. Now let's go to our denominators, and I'm just going to change colour of ink here to blue. So in terms of our denominators, we've got 8, 11, 14, 17. And each time we're going up by 3. We're adding 3 each time. So let's write down our multiples of 3. So 3, 6, 9, 12. And then we'd write 3n, because that's our multiples of 3. But our sequence is actually 5 more than the multiples of 3. So it's going to be 3n plus 5. So that's fantastic. We found the nth term for the numerators. We found the nth term for the denominators. So now we can just write it as one fraction. So it'll be 2n plus 5, that's the numerator, over the denominator, 3n plus 5. So that's the nth term for the sequence. Now we wanted to find the 20th term. So let's substitute in 20 for the value for n. So we'll do 2 times 20, that's 40, plus 5 would be 45. And then in terms of our denominator, 3 times 20 is 60, plus 5 is 65. So that means that the 20th term in the sequence would be 45 65ths. Now this can actually be simplified, because we can divide both the numerator and denominator by 5. So if we divide the numerator by 5, 45 divided by 5 would be equal to 9. And then in terms of the denominator, 65 divided by 5 is equal to 13. So that means the 20th term in the sequence would be 9 13ths. You could write 45 65ths if you wanted to. It didn't say you had to cancel it down, but I've just cancelled it down anyway. And that's it. Okay, let's have a look at our next question, question number 24. So question number 24 says that Martin has written the first 50 terms of a sequence, and the nth term for the first 50 terms is 150 minus 4n. And we've been asked to find which term is the first negative term. Okay, so we want to find the first negative term in this sequence. So it must start off being positive and then go all the way down and then become negative. Actually, let's check that. The first term in the sequence, we would do 150 minus 4 times 1 4 times 1 is equal to 4, so we do 150 minus 4, and that's equal to 146. So that's the first term in the sequence, and each time it's getting smaller by 4, so then be 142, it'd be 138, and so on. And you could just carry on that way if you wanted to, but the question is only worth 3 marks, so it would probably take quite a bit of time doing that. Another approach would be to use trial and error. So we could perhaps try the 30th term and do 150, take away 4 times 30. 4 times 30 is equal to 120, and 150 minus 120 is equal to 30. Or it's a calculator question, so you could just type that into your calculator. Okay, so we've tried the 30th term, and that's equal to 30. We want to find the first negative term, so let's skip on a bit. Let's try the 35th term. So we would do 150 minus 4 times 35. And if we type that into our calculator, we get that's equal to 10. So let's try the 37th term. So 150 minus 4 times 37, and that's equal to 2. Just typing that into my calculator. Now let's try the 38th term. So 150 minus 4 times 38. And if we do that on our calculator, we get that's equal to negative 2. So that means the 38th term is the first negative term. And the first negative term is negative 2. So we're asked which term in the sequence is the first negative term. I'm going to write the 38th term. So the 38th term. And that's equal to negative 2. And that's it. So with this question, what I done was I used trial and error, just trying different values. For n, I tried 30, 35, 37, and 38. And I found that 38 was the first negative one. So that's one approach. Now there's another approach, and that's to consider, well, the sequence starts off being positive, and then it's going to get smaller and smaller and smaller, and then become negative. Now what would be quite useful is, it would be quite useful if I could find out when the sequence becomes 0, or where 0 would be. So for instance, would it be in between the 17th term and the 18th term or something like that? So what I'm going to do is I'm going to see if 0 is in the sequence. So I'm going to take the nth term, 150 minus 4n, and I'm going to put it equal to 0. And I'm going to find out what position 0 would be in the sequence. And then I'll be able to find the first negative term once I know that. So to solve this equation, I'm going to add 4n to both sides. So adding 4n to both sides, that just gets rid of this minus 4n. So on the left hand side, we'll be left with 150. And on the other side, we have 0 plus 4n. That's going to be 4n. Now we want to get rid of this times by 4, so let's divide both sides of the equation by 4. And if we do 150 divided by 4, 150 divided by 4 is equal to 37.5. So 37.5 is equal to n. So n is equal to 37.5. So that means that 0 would be the 37.5th term in the sequence. So 0 is not in the sequence, it's in between the 37th term and the 38th term. That means the first negative term then would be the next term in the sequence, because if 0 would be in between the 37th and 38th one, the 37th one must be positive and the 38th one must be negative. So that means it would be the 38th term, and that's it. Okay, let's look at our next question, question number 25. Okay, so question number 25 says, the first 4 terms of a sequence A are 4, 9, 14, 19, and we've been asked to find the nth term of that sequence. So if we have a look at the numbers, each time they're getting bigger by 5. So let's write down the multiples of 5. So 5, 10, 15, 20. And that would be 5n. So that's 5n. But our sequence isn't actually 5, 10, 15, 20. It's 4, 9, 14, 19. So it's 1 less than 5n. So our nth term would be 5n minus 1. And let's just check that. 5 times 4 is 20. Take away 1 is 19. So the fourth term would be 19. So we're right. Okay, and then if we carry on, and then we're told the nth terms of sequence A, which is 5n minus 1, and sequence B, 2n plus 6, are added together to give the nth term of sequence C. And then we're asked, is 1000 a term in sequence C? So let's add together the two nth terms. So for sequence A, the nth term is 5n minus 1. For sequence B, the nth term is 2n plus 6. Let's add them together to find the nth term of sequence C. So 5n plus 2n is 7n. And minus 1 plus 6 is 5, so plus 5. So that means for sequence C, the nth term is 7n plus 5. And now we want to find, is 1000 a term in this sequence? So let's just put the nth term, 7n plus 5, equal to 1000, and then solve that equation. And if n is a whole number, such as 17 or 100, then you know that 1000 is a term in the sequence. But if it's a decimal number, then it's not. So if we want to solve this equation, we want to get the n outside. So let's take away 5 from both sides. So take away 5 and take away 5, and we get that 7n is equal to 995. And then let's divide by 7 and divide by 7, and we'll get that n is equal to, and let's work this out, 995 divided by 7 is equal to 142.142, and so on. So that means that 1000 would be in between the 142nd and the 143rd term in the sequence. So is 1000 a term in that sequence? The answer would be no, and that's it. Okay, and let's look at our last question, question number 26. Okay, so question number 26. So question number 26, we're told the nth term of a sequence is n plus 1, and then in brackets n plus 3. And we've been asked to work out the first three terms of the sequence. So there was another question a bit like this earlier where we had a quadratic sequence. This isn't a linear sequence, this n plus 1, n plus 3, because what this means is we've got n plus 1 multiplied by n plus 3. When you've got two brackets beside each other, it means you're timesing them together. And so this sequence, whenever you work out the terms in the sequence, you'll see that it's not getting bigger by the same amount each time. But if we want to find the first three terms of the sequence, we just need to substitute in 1, substitute in 2, and substitute in 3 for the values of n. So let's do that. So let's find the first term, So for the first term, we're going to substitute in 1. So we would have in the first bracket 1 plus 1, so 1 plus 1, and the second bracket would be 1 plus 3. 1 plus 1 is equal to 2, and 1 plus 3 is equal to 4, and then if we times them together, 2 times 4 is equal to 8. So that means the first term in the sequence is 8. The second term in the sequence, we would have, instead of n plus 1, we're going to have 2 plus 1, just substitute in 2 for the value of n, and then 2 plus 3. 2 plus 1 is equal to 3, multiplied by, remember, if the two brackets are beside each other, we're timesing them together. 2 plus 3 is equal to 5, and 3 times 5 is equal to 15. So the second term in the sequence is 15. And then the third term. So for the third term in the sequence, for our first bracket, we'd have 3 plus 1, just substitute in 3 for n. And then the second bracket would be 3 plus 3, just substitute in 3 again. 3 plus 1 is equal to 4. 3 plus 3 is equal to 6, and again we're timesing them together. And 4 times 6 is equal to 24. And that's it. So the third term in the sequence is 24. And that's it. So just to recap, we substitute in 1, and if we substitute 1 here, we get 2 times 4, that's equal to 8. If we substitute in 2, we get 3 times 5, that's equal to 15. And if we substitute in 3, we get 4 times 6, that's equal to 24. So the first three terms of the sequence are 8, 15, 24. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the nth term. I really hope you found this video useful. If you need any extra help on the nth term, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 288, there's a dedicated video tutorial there on the nth term. Alternatively, you can scan this QR code. But in this video, we'll focus on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it. Please subscribe to my YouTube channel as well. That'd be really fantastic. And also, if you've got any friends that find maths tricky, or if you want to share some good maths resources with your teachers, feel free to let people know about Corbettmaths, and that'd be really fantastic as well. Thank you. Cheers. Bye.